All right, guys, packet lesson 2-1. Let's see if we can make sense of that crazy pre-lesson. Seems like my automatic focus is on right now. Looks like it's getting wonky, but let's go ahead and take a crack at this. Now, I've got some multicolor markers, and if you've got some, that might be helpful in this note-taking craziness. Here's what I'm talking about. I look at this first problem, and I see cosine -1. And I need to know that this, the domain, my answer can only be less than 180 or greater than 0. And I look at this problem and I think, okay, here's a inverse sine problem. My brain needs to go to here and understand that the domain is given to me right here. And then I got this cosine stuff, and I know, oh, cosine, I just blew it. By the way, that should be the same as this. Sorry, think of that as yellow, my bad. I meant to go down to tangent, keep that blue, and then color that blue, and then say, hey, there's my domain for tangent problems. Now, what that means is your answer for sine problems can be greater than -pi/2, but less than pi/2. It means if you have your spinner here, you can create triangles anywhere up or anywhere down, but nowhere here. So if I went up here somewhere, that'd be a possibility. If I go down here somewhere, that would be a possibility. You see, you can spin your spinner up to 90 or down to -90, and that's it for sine. Now for cosine, this says you can spin your spinner greater than 0, so here's 0, so my spinner's here, all the way up to pi, because this is the domain of this function, because it's 1 to 1 within those boundaries, as I explained in the pre-lesson. So that means, don't even think about this. It means you can draw triangles anywhere you want in here to figure out where your answer is. As far as tangent goes, there's a subtle difference between tangent and sine. See, they're almost the same, except this can include -pi/2, and this can include pi/2. This cannot. It's strictly greater. Remember in the pre-lesson we were talking about asymptotes? So it goes pi/2 down to -pi/2. So if my spinner's here, it can go up anywhere it wants. It can go down anywhere it wants, but it cannot include -pi/2 or pi/2. Keep that in mind. And I think I'll be a softie and I'll give this to you for your quizzes or tests. Okay, with that in mind, I look at this problem and I say, hey, what do the instructions mean? Find the exact value. What I'm saying is, this is not saying use your calculator. This is saying do it without your calculator. So I say, okay, well, I see this problem. I know my domain is here. So I'm going to go ahead and take a little drawing, take a second. I know it can't be here and can't be here. Where in the world would cosine even be negative, first of all? Well, we know that all things are positive in the first quadrant, so we just got a little clue there. And now we can put all our eggs in this basket and just know, hey, we got to hunt it out over here. And so here's our 0, here's our pi. Because of our domain here, we know we have to hunt it out in here. So I'm going to think, wait a minute, where would my adjacent side equal 1, and at the same time my hypotenuse equals 2, because that's what this is telling you. By the way, this is a -1. And I'm like, wait a minute, I can see this thing coming. So there's my adjacent side. There's my spinner, that's 2, and I just drop it down here, and I ask myself, what is this problem asking me to find? It's asking me to find this degree measure, but wait a minute, there's more to it than just that. Because if this is -1, that's my 30, this is my 90, that would make this my square root of 3. Now watch this. I know this is getting messy, but that little degree measure in there would be 60. But if you put 60 degrees down for your answer, you'd be wrong, because 60 degrees is implying you're still stuck in the first quadrant. So the question is, how far did I have to spin my spinner to get to this drawing? And the answer would be 120 degrees. There's the exact value. Now this is the only one I'm going to do this for, but just to kind of help you know that you can check your work, I'm going to go second cosine negative 0.5, because that's what negative a half is. Hit enter. Oh, I'm in radians. That was a good lesson for us all. So I got to go to degrees, hit enter, and here we go. Second cosine negative 0.5, enter, and there it is, 120 degrees. You see, it's finding you the spinner value when you're doing these problems. That's the new kind of tricky part. Also, I demonstrated you got to have your calculator in the right mode. I also hopefully demonstrated that when you put a negative in here, don't use the minus sign. Use the negative. It will make a difference on a lot of your calculators. Okay, let's go to this one. Notice I've highlighted it pink, which takes my brain to here, which means immediately this has a domain, which means I don't even need to investigate any of that. See, that's the helpful part of this process. So now I have two quadrants to think about. Well, here's another clue. Where in the world could sine be negative? Well, it couldn't be negative in the first quadrant, because remember, all students take calculus. Cosine's the only thing positive in the fourth quadrant. All things are positive in the first quadrant, so I couldn't even investigate that. So this is telling me, remember, negatives, keep those in the top. It doesn't go in the bottom because the hypotenuse is never negative. So there's my opposite side, there's my hypotenuse. How do I draw this? Well, I got to draw it to the best of my ability. So there's my negative square root of 3. See, I already knew this was going to be my 60, so I made it a little bit bigger because the square root of 3 is always opposite the 60. There's my 90, there's my 30, there's my 1, and there's my 2. All right, well, the question is, what's my answer? Remember, your answer is supposed to be how far do you have to spin your spinner and where to get this situation. Well, in this situation, I would have had to spin my spinner, which, by the way, this is my spinner, it's where it ended, down 60 degrees, so that'd be negative 60. But before I leave that as my answer, does that even fit in this domain? Yes, because negative 60 is greater than negative 90, and it's less than positive 90. And I said I wouldn't do this again. Well, I'm not gonna. I want to get this packet lesson done. Okay, so, all right, back to this problem right here. So you can see, I'm sorry I accidentally covered it blue, but it's cosine, so we know it's yellow. So we also know that our domain is right here. So that tells me when I draw it, 0 to pi, that's what this is telling me. So I can spin my spinner anywhere in here, not in here, not in here. Now, where would cosine be negative? Well, definitely not in the first quadrant because everything's positive. So that would have to be over here. Now, again, square root of 2 is telling you, hey, that's got to be a 45, 45, 90. I mean, that's the magical number for 45, 45, 90. So we're going to take a stab at it over here and just hope. So that means this is my hypotenuse, 2. Remember, the negative goes with the numerator. So that'd mean my adjacent side would be negative square root of 2, which would make this the positive square root of 2. And some of you would be thrown off a little bit. And you're like, wait a minute, that's not what a normal 45, 45 is. But remember the rule. Remember the rule is x square root of 2. In other words, you take this, you multiply it by the square root of 2 to get this. And you'd have to ask yourself, if I multiplied this by the square root of 2, would I get 2? Yes, you would. This one's just given to you in a little bit trickier of a way. Well, what's this problem asking me to find? It's asking me to find how far did I spin my spinner right there. This is your answer. But you have to first discover what that little smidgen is. That little smidgen needs to be a 45-degree angle. That's the only way you could have these dimensions. So what would this be? Well, it'd be 180 minus 45, which would be 135 degrees. And that's the way these are. So let's continue on these. Tangent. All right. Well, we already know that this is our domain. So we're going to say, okay, we know that our domain has to be greater than negative pi over 2, less than pi over 2. See, this is negative pi over 2. This is pi over 2. So I can go down to here, up to there, but I can't be in here. Well, how could tangent be positive? Well, if I drew just a random triangle down here, this would be negative, positive, positive. Tangent would be opposite over adjacent. That'd give me a negative answer, so I know I can eliminate quadrant 4. So I know I'm in quadrant 1. Well, how could tangent be 1? That means opposite over adjacent. That tells me if this equals 1, then the opposite and the adjacent must be the same. That means this side and this side have to be the same. There's only one way, and that is if that degree measures 45 degrees. All right, now we're going to get into those weird ones, quadrantals. Remember what tangent is. It's opposite over adjacent. How could tangent end up being 0? My opposite would have to disappear. Well, this one actually just got really easy. If our domain is anywhere up to pi over 2 or down to negative pi over 2, I need to draw a picture where my opposite side disappears, and that's the only place where my opposite is 0, and that's exactly at 0 degrees. That's a hard one, but it's easy if you see it right away. All right, another weird one. How in the world could cosine ever equal negative 1? Well, by definition, cosine is adjacent over hypotenuse. So that means the adjacent side would have to equal my hypotenuse, but the adjacent side would have to be negative. So where could I spin my spinner to make that happen? Well, you got to stay between 0 and pi. You see that? Which means I got to spin my spinner from here to here. Anything's possible in there. So this is impossible, impossible. Where does this happen? Think about it, guys. If I spun my spinner all the way over to pi, here's my adjacent side right here, and that would be negative, and my hypotenuse would be positive, and that's where it would happen, at pi, which is the same thing as 180. All right. Where could sine be 0? Remember, sine by definition is opposite over hypotenuse. The only way you could have a fraction equal 0 is if the numerator equals 0. So that's giving us a huge clue. It's saying, hey, where does the opposite side equal 0? Well, if we just look at this picture, it comes up again. The only place it disappears is 0. So again, this would be 0 degrees. All right. Running out of time, but these problems are a little simpler. So this is actually asking us to use our calculator. So this says express in degrees. In other words, go to your mode, go down, make sure, notice how my degrees is highlighted? Make sure yours is highlighted. So I'm going to clear that out. All you got to do is type this in. So I'm going to go second sine. Let me get my fingers on here so you can see it. So I hit my second button, and now I hit my sine button. Notice it's exactly what the problem looks like. And there's a negative there. I'm not going to hit my minus sign. I'm going to hit this guy down here. So negative 0.6. I'm going to hit enter, and I get negative 36 point, I'll just call it 8, negative 36.8. Now, does this fit in sine's domain? Yes. Okay, it's greater than negative 90, it's less than 90. You got to keep that in your back pocket the whole time. Now I'm just going to go, second cosine, negative 0.23, enter, 103.2. See how quick these are? Or just 0.3 if you round. Okay, I've got less than a minute. So this says express in radians. You know what that means? I got to go to mode, go down, hit enter, clear it. Now I'm in radian mode, and all I do is go like this. Second tangent, 22.8, enter, and I get 1.52 radians. That's what that is. Running out of space here. And then for the last problem, second cosine, negative 0.853, enter, and it's 2.59. And that finishes the packet lesson.